Hello folks, welcome back to our IBM 1401 exhibit, our dinosaur computer from the 1960s. This is Mike Alba, and we are with our 1401 exhibit here using the machine we call the Connecticut, and we're going to attempt to compile a FORTRAN program.
Right, and this is the first example in the manual. And we figured that was as good as any point to start.
All right. Okay, let me take it from another angle here so we see the cards.
I'm missing a card weight.
Okay. Important. Oh, we need to load the tape. And we have been laboring for a month.
A few hours a day.
A few hours a day.
A week.
The tough part was to remake the tape of the FORTRAN, but we think we have made a good one. We don't know.
We can hope.
We can hope. So. So we're afraid the beginning of tape marker fell off the tape, or we didn't see it. In which case the tape will rewind and go off the reel. There you go.
Oh,
wasn't there.
Alrighty.
Cool. Right. Well, it read a few records, and then I saw the tape move, not the reels, but the tape.
Got a reader check.
Oh, that's good news. That means it wants to read something. And it's not reading the other cards. It's not feeding them. I think it wanted to print something. That's why it stopped. Oh yeah, that's working. That's chooching over there. It compiled?
That's the listing. It lists it as it reads it into memory.
Good credit. Well, that's as far as we have ever gotten that.
Oh.
So what's the next step?
The usual last card restart.
Oh, okay.
Should have put a blank after that.
Okay.
Whoa!
And?
Not so good.
Oh wow, we have a whole bunch of red lights here.
Yeah.
Houston, we have a process error, a reader error, a storage error, and a B and an A register parity problem. Well, this is as far as we have ever gotten, Michael. This is pretty amazing.
And this is the instruction it was trying to run, and it got a.
It's a 3.
It's an L. It was doing a load, which could be a tape read.
What the heck is that?
But yeah.
So you have the little character cheat sheet on that one. What is BA821? So the character we have down here is a BA821, which is a dot, which Michael, who speaks currently speaks fluently FORTRAN assembly. We have B821, and it should, but yeah. So when we have a parity error, it should have this bit on.
It should, well, anything in memory should be an odd parity.
And then we have, so this bit, which is parity bit, should be on, and it's not. And then it went, that's not a good number, and we got the process error and the storage error, and everything went haywire.
We could do the time-honored thing that customer support always tells you to do: try it again. It's an opcode 1, which means read, but...
There we go.
Oh, there we go.
Okay. How come he didn't read the tape program? Oh, he did! There we go. Number 2, reader, check the last card. Okay. Oh, it's compiling. It is compiling. Doing something. All right, reader, stop. Stop. Finished. Cleaning.
So I think if I press start, it will run.
Yeah. So it's just finished compiling. Went to a halt. It's doing something. Just did it. You got it.
It's still thinking about something.
It's printing numbers. What is it supposed to do, by the way?
I forget at this point. It's been a couple months since I typed that in.
It's in deep trance here. It's calculating hard. It's a very, very slow machine at doing scientific calculations. So FORTRAN is really a stretch for the 1401. I mean, it's totally amazing that they were able to put it in there. So it's calculating a table of something. And it just halted. So, Michael, I think you did it.
Compilation and running.
Why don't we look at the output?
Oh, I don't know, but okay, sure.
Start of FORTRAN compilation. Okay, that's the one we got.
Right.
Last time with the parameters. All right.
Machine size specified is 8,000. Meaning characters of storage. Actual machine size is 16,000. So
we're maxed out at 16,000 characters.
Yes.
So we have the biggest, meanest machine around.
And
so that's a listing.
That's a listing of the program.
And you still don't remember what it does?
It says matrix arithmetic.
All right.
Okay. And then the result of the compilation, it says, I believe, 800 input characters. So the whole program, modulus is 5, that's the size of integer variables. Mantissa is 15, the size of the mantissa on a floating point variable.
Then where the variable are stored in memory,
yes.
Assignment, blah blah.
And then that's the end of compilation.
Oh, you didn't
press start to go.
Oh wow, there's a user interface of this thing. Oh, it's a Hilbert mat. Oh, it takes a matrix, does the inverse, multiplies it, and invert it the second time. Oh, pretty cool.
And it takes a little longer than your iPhone would if your iPhone had FORTRAN.
Oh, it does?
Yeah.
Wow.
That's it.
I didn't think we would go that far. That's pretty cool. Hey, wait a second.
What program did you compile something?
Yeah.
You're listening? You're kidding.
No.
My goodness.
These are examples 1 and 2 from the manual. The first comments on them say, you know, on page whatever of C24- whatever.
So how many decades did it take to run the program?
No, it was pretty quick actually.
Not bad considering a 90 kilohertz machine.
I can't believe this.
And also better.
Look at this.
Better for tubes.
Floating point numbers. Floating point format. You ever imagine floating point format coming out of the 1401?
I not only imagined it, I did it back in the day.
But it wasn't an IEEE format, was it?
No,
IEEE format didn't exist then.
All right.
So how did you get the big record broken into?
Well, that was complicated. So one of the most difficult steps we had to go through to revive the FORTRAN compiler was to create a tape of it. In order to understand how we did that, I have to show you a little trick that we use. So if you go to the back of our tapes here, you will see that one of the connectors, this is a regular one, but this one looks like it has a suspiciously modern cable attached to it, and it goes to a black box here, and this is our tape emulator. Let me show you from the other side. So here, pay no attention to that evil computer. It just allows us to send commands to the tape emulator. So this guy is the other side of the box. I can open it up. And it has serious hardware in it, designed by a few of the restorers. And so this hardware pretends to be 6 vintage tapes to the 1401, and you can see the interface here on the computer. And right now I have 3 open, and you can do as you would expect in a real tape, right? You can load it, you can change the density, you can start it, and basically what that reproduces is the same array of buttons that we have over here on the real tape. Give you an idea of what's in the file. That's the executable mounted on tape 1. So merge program over here. Upload. Rewind start. This is the data. So this is the original tape formatted in a way that the tape emulator understands it. Go to rewind, start. Alright, both at 0. So we're trying to recreate a new FORTRAN tape on the real tape from the emulated tape. So step 1 is to put it in. And you have to wind it past the beginning of tape marker. If I can, there it is. This guy, that's the beginning of tape. So if I'm past that, it will rewind and find the load point when it gets on the reflective marker. Alright, load, rewind. There you go, it's loaded. Start. And then we make it tape number 3. So this is going to be a real tape number 3. There we go. So now it's working. It's writing on our tape, printing it, and then we should see it on the emulator advancing. Yes, at record 10,093, 1122. So it's executing this program, taking the data from this emulated tape, writing it to this drill tape, and having a ball printing what it's writing, which we didn't really want to happen, but no. See, that's not bad. So that's the FORTRAN tape. It's a pretty darn complex program.
It's listing it as it's writing it on tape.
So now that we have recreated the FORTRAN tape, we are not done, because we need to recreate the source deck, and we didn't feel like punching it by hand. So here is the source, and you can tell it's a short FORTRAN program with a little auto punch program at the beginning of it. So we'll get the 1401 to punch it for us, and that's the self-executing tape that will punch the card deck. File, load rewind, start. Okay. Back to the real machine here. Two ends to the 1402, that's the reading end. And that's the punching end. Alright, so now we're going to punch a set of cards. Yeah, so it's 12 edge on this side and 9 edge on the other.
Yeah, because they're supposed to be able to mix.
Right.
Mix in one pocket, they want to be both facing the same way.
So now we are going to do similar thing, is load the emulated tape program and have the 1401 punch a FORTRAN source card deck. Recreate, right? We're punching. So the blank cards go here. Whoops, already done. And the fresh deck is over here. Does it have holes in it?
It has holes in it. I'm checking whether the card says end. And it seems to.
This one has.
So that's the end card of the FORTRAN source.
Okay. Yeah, so the 1401 punches real fast but doesn't print what it has on top of it. Let's go duplicate some cards to see what's on it. So the first card should be parameters.
Yeah, like the options to the compiler.
Right, so what Michael is going to do is going to duplicate the card on the 026, and the 026 has a printer on it. So it's going to reveal what it actually has. And it says, so yes, the first card just showed the duplicates. So now we can see what's on it. It says param
I9Z0515.
Right. Can we get a FORTRAN statement? So basically it's one FORTRAN statement line per card. Might be another comment.
It does look like another comment. And it says matrix arithmetic.
With, yeah.
We should be getting into actual code soon. Probably a dimension or something like that. Yeah, that's real code.
Yeah.
And And yeah, so that's declaring
Okay,
our arrays.
Finally, we have a FORTRAN statement here. Dimension A77, vector 7, B77. All right, cool.
All right.
So the whole deck is like this, and then the last one is an end card. Cool. That's the end card. So one parameter card, then the whole FORTRAN thing, one line, no, line by line, and then an end card, and that's the source code. That's your file. Now we can go try to compile it. Source code over there. I have to make this tape 1, right? Yeah. So this now is the real thing, tape 1, which I actually have to rewind. Okay, so we rewind our compiler, a freshly made compiler. I have to unhook the emulated one. So now we're back into a historically correct state. I don't need the emulator anymore. Unload, nunk, gone. So this guy, all that modern ugly stuff, that's not counting anymore. We're going to do the real thing. Alright. Do we have the printer ready? It's all good. Alright, compile. Is it waiting for the reader? Yeah, it's waiting for the reader. There you go.
Oh, okay.
Reading the cards.
Have to get the last couple cards.
Okay. And now
compiling.
Now it's compiling. Machine is working pretty hard. And so it does it one pass at a time, and so it's reading the passes right here. 63 passes. So just read another pass. And it's rewinding, it's done. Alright, so now we're going to run the program by pressing start. And it is calculating. There you go. Oh, that's it. Did it. So took a Hilbert matrix, inverted it. That took it a while. Then it multiplied both and got identities. So one on the diagonal, mostly 0. Otherwise, mostly. And then it inverted another time, and that was the end of the FORTRAN scientific demo.